So this is a follow-up to Lab 4, the digital lock. And there were some mistakes that were made, not just by our class, but by previous classes, and I wanted to run through a couple of the common ones, and hopefully you'll learn from these. So if we've got something like this, where we've got three states, S0, transitioning to S1 or S2, or staying in S0, and this might be the case where you're checking the push button and looking to see whether the code is correct. And so I've written here some code just to execute case S0. So we read the two pins, we check if they're both 1, and in that case we go to state S1, and if they're 1, 0, we go to state S2, and if we've got a 0 on the first one, which is the push button, then we stay in state S0. Now there were a couple of different things that I saw during lab, and again this was not just this semester but previous semesters, and I put together 3 examples of things that went wrong. And so I'm going to flip through these very quickly and want you to pause the video and identify what went wrong. So here's the first case. What's wrong with this version? Here's the second case. Slightly different error. And here's the third case. A little bit of a change in the transitions. So again, pause the video. Think to yourself for all 3 cases what went wrong. And then restart the video and let's talk about it. Alright, hopefully you took some time to think about this. Let's go back to the first error. What's wrong between this one and the previous case? Well, the transitions are the same. It's still 3 if statements. If P equals 1 and C equals 1, if P equals 1 and C equals 0, and if P equals 0. So there's no change there. Did you notice that there's no inputs being read? If we compare to the first case, we read both the pin 1 and the pin 2 and store those values into P and C. In this case, we haven't read pins 1 and pin 2, so we're relying on our previous reading of P and C. Well, that can be problematic. If your previous reading was a while ago or in a different state, you may not ever have a way to transition out of this particular state. So what is the final state for an input of 0, 0 or 0, 1? Well, we don't know because we haven't read the inputs. So the inputs are locked into whatever the previous time we read them are. How about the second case? Notice that we're reading the inputs again in this case. Did you notice that the transitions, here we go, there's our transitions. The transitions are not unique. In this case, S0 can go to S1 on a 1, 1 input, and S0 goes to S2 on a 1, 0 or a 1, 1 input. So if you get a 1, 1, where does it go? Well, if you follow through the logic here, in the first case, you're going to set the state equal to S1, but then you're going to read the next one and say, well, that's also true, so now we're going to use set it to S2. So we'll never actually get to S1 with an input of 1, 1. If we get an input of 1, 0, we'll still end up in S2. So that's not good. And the key here is that if you look at your inputs and their transitions, these two can be the same. And every combination of inputs should take you only to one other state. So make sure that your input transitions here are not going to be common between 2 different arrows. In that case, it's an error not of the code. The code has been implemented correctly. It's an error in the state machine design. How about the third one? What's wrong in the third case? This is, I think, the trickiest one, and this is one that took quite a while to debug. Notice that the inputs are being read again. 1, 1 and 1, 0 for our transitions to states S1 and S2, so those are unique again. They're being implemented correctly. They both have if statements. So the only thing that's going on here is this last one, this else. Now, if you think about this, what's going to happen is that we're going to read the first if, then we're going to read the second if, and if that one is not, the condition is not met, we'll go to the else statement. So think about the case of P and C both being 1. If P and C are both 1, then we'll check this first case, and we'll say, okay, that's true, so we'll set state equal S1. Then we'll read the next if statement, and we'll say, well, that's not true, and since that's not true, we'll have to go to the else, and so state will be state equals S0. And so again, a 1-1 doesn't take us where we think it's going to be. It doesn't match the design of the state machine on the right there. It's going to take us back to S0. Inputs of 0, 0, and 0, 1, they're both going to take us to S0. And a 1, 0 is going to correctly hit that second if statement and take us to S2. So again, we can't get to state S1. And this is because we've got 2 if statements followed by an else. So I would say in this case we would have been better off with 3 if statements with all having unique combinations, or we could have done an if, an else if, and an else. That would have also worked. Although when you have if and else, you have to worry about, did I forget a case? If I forgot a case, then there's a problem that it's all going to get dropped into the else statement as well. So there's 3 different possible ways that you could go wrong, and they look pretty similar. So be a little careful. Make sure your state machine design is completely correct, as in example 2. Make sure that you're always reading the inputs, as in example number 1. And make sure that you're very careful with your if and else statements, as in example number 3. So hopefully you had a successful digital lock, and if you had any residual questions, maybe this cleared it up. If not, we'll talk about it in class.